Hello, everybody, and welcome again to Facet Nation, a gemmology podcast. My name is Simon.
And I'm Lucinda.
How are you doing today?
I'm all right. We've got an exciting one today. One of the most interesting instruments in the land.
Yeah, so this is basically going to conclude our light episodes. We're moving on to the refractometer and how that works and how it's very, very useful.
Very useful. But before we do that, Simon, you've got a couple shout-outs.
I do indeed. So Henrietta messaged me on LinkedIn, and she messaged because she said she found our exam prep episode really, really useful. She's a distance learner, and she was saying she feels a bit isolated because she doesn't have anyone to sort of talk to, bounce ideas off. And the fact that we felt anxiety about the exam and things like that gave her a bit of comfort. So it was really nice to hear her get in touch and message us. Another guy called John introduced himself. He was specifically asking about optic sign, actually, which is very pertinent because we're going to talk about that today with the refractometer. So John, this one's for you. And also a guy called Chris. Chris is an auctioneer. He messaged me on Instagram and we had a chat, and he said he's really enjoying the podcast as well. So thank you, Chris.
Yeah, thank you everybody so much for listening. We love getting your messages. It makes us really happy. And we're glad that the exam prep episode was useful. I know it can be really scary, especially when you're kind of off on your own island and wanting to know what to expect. So we're happy that we could help.
Yeah, absolutely. Okay, so let's get into it. The refractometer.
Yes, so this instrument you know about in the early stages of your life as a gemmologist, and it becomes increasingly crucial, I would say. So a really good one to know how it works and why and how to use it.
Yes, I have likened the not having a refractometer to going into battle with a spoon.
Which I think is a good metaphor.
Yeah, because you're not going to get very far with a spoon.
I mean, you could, but technically you could kill someone with a spoon. So you could identify a stone with a spoon, but it's a lot easier when you have a sword.
I suppose if you're John Wick, you might have more chance with a spoon or indeed a pencil.
So we have spoken extensively about refraction. Of course, you guys might be familiar with how it works. This was another one that Simon had an interesting metaphor for that we then had to flip. But essentially, optically denser materials cause light rays to refract or bend. And that's what's happening in gemstones.
Yeah, so things to remember are that when light enters an optically denser material, it bends towards the normal, and when it exits, it bends away from the normal. And the normal's that sort of dotted line that you plot in at the point of incidence going sort of vertical through the material.
Exactly, and these are going to be unique for every material, which is really helpful because it lets us identify them by determining how far that light is bending or refracting. Hence the name refractometer. Reading that you get is called a refractive index. Every material has a refractive index. And there are a couple of important ones to keep in mind. You will have a list if you're doing the GEMA exam. In real life, I found that just kind of knowing the general cutoffs is more useful than knowing exact numbers because, something's an amethyst or it's a sapphire. There's lots of ways to tell those apart, but RI is a pretty useful silver bullet. Simon, what are the important ones to remember for the exam, though?
So I would say important ones to remember are corundum, because generally in your life as a gemmologist, you're probably going to see a fair bit of sapphire and ruby. So you will have your suspicions that that's what it is, but to confirm that, the refractometer is going to do a really good job. So you want to commit to memory, just so you're not constantly flicking through books. There's important ones that you want to know. And the refractive index for corundum is 1.76 to 1.78. That refractive index range is what you want to commit to memory. So if it's around there, it's more or less going to be corundum.
Yeah, and then a really key one that we've spoken about before is spinel. So 1.718 for natural spinel and 1.727 for VFF synthetic. So useful. Memorize these guys. They are like a warm hug when you see them.
Like a warm hug, yes. So how does the refractometer work?
What a question. So the refractometer works on the basis of total internal reflection. We've explained this. You guys can go back to some of our older light episodes to get the full download. But essentially, total internal reflection utilizes angles to stop light escaping. So an angle of incidence greater than the material's critical angle means that the light gets trapped and it kind of bounces and reflects back, and that's what makes a really beautiful cut. And so that is what the system that we are relying on here.
Yes, total internal reflection is essentially how it works. So when we're talking about a refractometer, the instrument itself, let's talk about the sort of component parts to it. So it's effectively a prism with a high refractive index glass table, and then a numbered scale, a mirror, and an eyepiece.
Yes, and you are going to want to learn how to draw what we are about to say. That is always good practice. All of your instruments, make sure that you can at least roughly sketch out how they're working. Just a note. So you want to make a note, especially of the path that the light is taking.
Yes.
And it starts with a light source. So tell me a little bit about the light sources for the refractometer, because they are different from depending on the machine that you have.
Yeah, so basically the light source enters the refractometer through the bag, and then as it passes into the refractometer, there's a hemi-cylindrical high Ri glass, like like a hemicylinder, if you know what that means. It's like a half a cylinder.
Okay, got it.
And obviously, if it's half a cylinder, the point where it's halved is flat, and that is effectively your glass table. Now, this glass has an RA of 1.96, and that glass table that you're created is very special. It's very soft, though, and it can scratch very easily.
Actually live in fear of scratching my refractometer too.
Absolutely, yeah. So if you accidentally touch it with something that's hard, like the point of a diamond or something,
honestly,
or your tweezers for that matter. So don't be using tweezers when you're using a refractometer, because the metal in your tweezers is no doubt going to be harder than this very soft bit of glass. And if you scratch the glass, your refractometer is knackered.
Yeah, it's one of those things that's too expensive to replace the components, so you just have to replace the entire shebang.
Yeah,
and they're
if
expensive.
If you're studying with Gem A, you get given one when you do the diploma course. But if you're studying with the GIA, I do believe you have to buy it yourself.
Really?
Yeah, because you get given it, you don't really respect how expensive it is. But replacing one would be a big drag.
Yeah, I lost my dicroscope once, £30. And of course my conoscope, but that was only $7 plus VAT.
But I mean, that's painful enough. But like your refractometer is like 400 or 500 quid.
It's crazy.
So yeah, you want to be very careful with it. Going back to the hemi-cylindrical glass, that is effectively forcing light into your usable angles. So it's sort of directing traffic and making sure that the light that enters the back of the refractometer is approaching the material at an appropriate angle in order for you to get total internal refraction.
Yes. So how the light behaves is important, but also the light that you're using is really important. So you want to be using a monochromatic source of light. So that basically means that it's one color, one wavelength. And in this case, we use sodium yellow light. If you do have the Gem A refractometer, it actually has a filter at the back where the light source goes in that will filter for sodium yellow light. Other refractometers don't, so you want to get a light source itself that's going to give you that wavelength of light. And this is the agreed upon standard for reflective. We're struggling.
It's a tough one, isn't it?
Refractivity testing. So you can take an RI with white light, but the different wavelengths reach total internal reflection at different angles. And so that produces a spectrum, which you can actually see on the numbered scale. So you can take a reading, but you want to make sure that you're reading from the yellow bit, basically. And it just adds this whole layer of drama that you do not need in your life. A sodium yellow lamp is just going to make everything more accurate. It makes it easier to read. And the wavelength of sodium yellow light is 589 nanometers. So it's actually, Simon has put it's 589.3 nanometers, just in case you didn't think he was precise enough. So a good one to remember.
Yeah, and this wavelength is basically the agreed upon standard in the industry where you would take a refractometer reading.
Yes, and hopefully your equipment's doing a lot of this legwork and a lot of this thinking for you, but it's important to know that kind of fundamental just in case you're ever out with somebody's cowboy refractometer. It's where the yellow and the green meet. That's what you're looking for.
Yeah.
It is quite pretty, those rainbows on the scales.
It is. It's always nice when you've got a bit of you can see the full spectrum, and we will talk more about that when we get onto the spectroscope when we tackle color, which is
first,
quite
the
a
most
daunting task.
frustrating part of the refractometer, which is the fucking RI fluid.
Yeah, that is.
Tell me about it, Simon.
Like, practice makes perfect with the RI fluid. So basically, on the table of your refractometer, you need to be putting a very small drop of contact fluid. And when I say very small drop, you literally need the tiniest little drop. And
you won't know it until you see it.
Yeah, so you kind of dab the little stick in the pod into the liquid, and then like a whole load of it stuck on the end of the stick. And if you dab that straight onto the glass table, the drop's going to be massive. So
you just get a blob.
Yeah,
on your
so I kind of like scrape it round a little bit to take most of it off, and then dab it on. But what you will find is that you'll look at it after some practice and think to yourself, that looks a little bit big, because if your gemstone's like quite small, then you don't want a great big lump of contact fluid. It's not gonna work properly. So you think to yourself, I know what I'll do. I'll get a tissue, because you should always have tissues with you in order to wipe the contact fluid off. We'll get on to why in a minute. And you think, you know what? I'll just sort of dab a bit off, and it'll be a bit smaller. What happens is when you put the tissue, it sucks the whole thing up, and then you've got no contact fluid, so you have to start all over again.
The worst is when we ran out of tissues in class one day and we only had paper towels, but the paper towel is so absorbent that nobody could get any RI fluid on their thing, because it was like everything was gone. It was such a fucking faff.
It's really, really important, though, that you have the right amount of RI fluid, because basically that RI fluid is allowing proper optical contact with the glass table. And without the contact fluid, air is going to be trapped between the gemstone and the table. And then, again, your refractometer doesn't really do the job that you're requiring it to do.
Indeed. And RI fluid has an RI of 1.79, but higher RI fluid can be obtained. So some garnets, they have an RI that kind of hovers at the top end of the scale, like around 1.80, and sometimes it can be important for distinguishing between garnet types. So you can get higher RI fluid that will help you get a clean reading up at the top of that scale. Only gem material with an RI lower than the fluid can be tested. Otherwise, the total internal reflection occurs at the boundary between stone and fluid, and no reading is obtained. And it's also worth noting that a faint shadow edge might be caused by the contact fluid itself. So be careful not to confuse that with the gemstone that you're reading. So always have a kind of rough idea of where your RI fluid is sitting on the scale, so that when you see that kind of shadow edge, you're not mistaking it for your stone, especially in cases where you might be getting a negative reading.
Yep. So the process here is basically place your gemstone, usually table side down, onto this small drop of RI fluid that you've finally managed to succeed to get there. It's very important to ensure that your stone is clean, and to make sure that the table facet isn't heavily abraded or scratched, because, again, that won't work. The refractometer requires a clean, polished surface in order to work. And if the material is rough, for example, like unfashioned, unfaceted, a carving, or heavily scratched and abraded, you'll need to find the flattest, most polished surface possible, but that might not do the trick. So yeah, bear that in mind.
Yes. So what are we actually looking at? Like everything, this is all about the light. So the light shines through the glass table and into the stone through this RI fluid. Some of the light passes through the material, so it's transmitted, but it's the light that approaches at a greater angle than that material's critical angle that we're concerned with, because that's what is bouncing back into the refractometer. So it goes up, hits the stone, and reflects back. This light never actually passes through the stone, but the angle at which it re-enters the mechanism is completely controlled by that gem material. So if the material is anisotropic, it produces two plane polarized rays, as the light does when it, much the same as when light does enter a gemstone and refracts. Okay, so that's fine. And then these rays, or just a single ray, if the gemstone is isotropic, is reflected back onto the numbered scale, then onto a reflective mirror-like surface, which reflects them again up through an eyepiece and into your eye. It's a bouncing around.
It's a whole lot of bouncing around, a lot of important, very controlled bouncing around, but
Indeed.
It is a whole lot of bouncing around. And this is what we mean about drawing it. And if you can sort of get into your head what the light's doing, then it just makes everything sort of make a lot more sense.
Exactly. So essentially the light is hitting the stone and the stone is telling it how far to bend. And that's what you're seeing on the scale, is how far that particular material is bending the light.
Yeah. So if you imagine the light which was reflected off the gemstone is at a steeper angle than the critical angle, yeah, the light that is at a shallower angle no longer exists because it's gone through the material and gone away. So naturally, there'll be an edge where the light and no light meet. And essentially, the critical angle, this is essentially the critical angle itself. And it is the meet point between light and dark, which casts the shadow onto the numbered scale. And this shadow edge is where you take your RI reading.
Amen. And if you're looking through the eyepiece at this point and you don't see a shadow on the scale, or the entire scale is in shadow, that's called a negative reading, and it basically means the RI of the material being tested is higher than the RI fluid. So this happens with some garnets, this happens with diamond, which you shouldn't really be testing on your refractometer anyway, because it's going to scratch the shit out of it. And it can really be easy to look at a negative reading and think that you fucked something up, but they're actually a pretty common occurrence.
Yeah, so don't get stressed. If everything's sort of looking slightly dark and shadowy, it's probably because the RI of that material goes above your glass table and or your contact fluid, and you're going to have to rely on other tests. Zircon, for example, is a good one.
Yeah, but that's got that sub-adamantine luster you can always rely on.
Yeah, and you're doubling, so you're all right with zircon most of the time.
He's our friend.
Yeah. So if you do see some portion of the scale being in light, we know we're in business and we can actually get a reading. So you need to find that shadow edge. If there's only one shadow edge, then that's great, perfect, make a note of it. Don't think you're done though, because as we know, gemstones are a little bit tricksy, and one shadow edge does not necessarily guarantee that we have a singly refractive material, does it?
No, it certainly does not. There is a chance that if you think that you're looking at one shadow edge, what you're actually looking at is a material with a very small birefringence. The birefringence is essentially the space between the shadow edges. And the way that you can tell if this is the case is your handy polarizing filter. I love this thing. I use this thing constantly. Pop it on your refractometer eyepiece, give it a little turn, and if you see the shadow edge kind of nudging up and down, that means it's actually two shadow edges with a very, very small birefringence. You can also try turning your stone. The birefringence may change at different angles, but always just give it a quick double check. It's so much better to take the few seconds and check it.
Yeah, so that polarizing filter is really useful because, like you say, when you do sort of spin it around and you're getting the different, and you're sort of blocking out each one, you will see it blinking, and that blinking isn't going to happen if it's singly refractive. Mm-hmm. The other important thing to do is to move the stone too. So you need to rotate it around on that glass table 360 degrees. Even if you're only seeing one edge, because if it doesn't move and stays where it is, then like fine, this is cool. We've got it's isotropic and we only need that one edge. But you might be looking through an optic axis though, which is a direction of single refraction. At which point, testing on a different material might be necessary, like one of the pavilion facets or something like that. Likelihood is though that you've used your polariscope prior to this, and you're going to know that it's isotropic. So you're effectively just confirming your suspicions, and you're getting that important RI without getting any confusing information.
Exactly. And we've touched a little bit on where these shadow edges falling makes a really big difference or is really important. So garnets is a huge one for this. Pyrope and almandine can actually be separated by where their single shadow edge falls on the scale. So really important to remember that or check that or be aware of that. You can't just say pyrope almandine and wish for the best. And then, of course, spinel. So as we say, blessings upon blessings. When you see that perfect, clean 1.727, you know exactly where you're at, and equally the 1.718 shadow range.
Yes. So the scale itself that you see has a range from 1.4 to 1.83. And 1.4 is going to be at the top of the scale as you look at it, and 1.83 at the bottom. And it has lines at 0.01 intervals. The third decimal place is judged by the eye of the observer. So, for example, if you see a shadow edge that is exactly between 1.76 and 1.77, your reading, which has to be to 3 decimal places, is going to be 1.765. So you get what we're getting at here.
But what if you see 2 shadow edges, Simon?
Well, that means we have an optically anisotropic material, don't we?
You do.
The options get a lot greater.
And more annoying, I would say.
Much more annoying, yeah. It's very important to be specific and knowing what to look for and when.
Yes. So I've totally lost where we are now.
That's okay. Um,
I found it.
so another important thing to remember is that depending on the materials, these rays or shadow edges, as we're now referring to them, have variable speeds in different directions. So some of them move, and they move when you rotate the stone.
Yes, and as with all things in gemmology, you want to be really thorough. So when you are recording RI readings for optically anisotropic materials, you want to make sure that you're taking 2 readings at the highest and the lowest points. And what that means is you have to be really careful and rotate the stone until the edge moves and then starts coming back on itself. So peridot is a really fun one for this. You know, they start off a little bit like this, and then they grow bigger, and then there's a point where the gap starts moving smaller again, and that point where it's just on the edge of turning is where you want to take your readings. And once you have the maximum and the minimum values, you subtract the minimum from the maximum, and that's your birefringence, which is another really helpful clue when you're trying to identify something. Tell me why, Simon.
Yeah, there's some really important birefringences that are pretty consistent and are going to help you identify a certain material. The birefringence is the numerical difference between the maximum and minimum reading, which is why you deduct the minimum from the maximum. And it's very useful with some gemstones. Like you just mentioned, peridot is a really good example because it has quite a big and consistent birefringence of 0.036. If you've got a large birefringence, it generally means that you're going to see doubling too. So peridot, you're going to see doubling of the back facets as you look through, which is something we've spoken about. Another important one to remember is quartz. That's pretty consistent, and it's pretty consistent at 0.009. However, there is a bit more overlap with gem materials here, so isn't exclusive to quartz within that RI range. It's just a useful additional endorsement if you're looking at something and you suspect it's quartz. That's just going to be something that you can add to the list of this is telling me quartz.
Yes, and as you kind of start getting deeper into this, it all starts making sense, and you'll be able to rule things out in your own mind based on how all of these factors are interplaying. Because as Simon says, there is a range kind of in the 1.54 to like 1.6 where there's a lot of stuff. And so you have to start relying on different indicators to get you to where you're going. So remember that uniaxial stones, as opposed to biaxial stones, will have one fixed RI and one that moves. So which of the two that's fixed and which isn't can also be really useful information. So if one edge is rooted in place and it's the edge with the numerically lower reading that moves, then...
That's in most cases.
Yes. Sorry. Yes. So that's uniaxial negative. And if the higher one moves, that is uniaxial positive. Craig had a really good way to remember this. Was it that you like to keep positive things close to you?
Okay, yeah, that's right. Because as you're looking at the scale, it kind of is the higher ones are going to be positive. So if your higher edge is moving up and down the scale, that is physically closer to you than the negative ones, because the negative ones are going to be lower on the scale. So I used to think of it as like negative minus, so it's a lower number, positive
plus is a higher number.
Yeah.
And it's really important because as we say, quartz can be in an RI range that incorporates a load of other gemstones, but it is also the only widely commercial standard refractometer testable gemstone that is uniaxial positive. So zircon and synthetic moissanite will give a negative reading. The RI is above 1.8, and phenakite is not exactly abundant in jewelry. So being able to tell whether something is uniaxial positive or negative can be really, really helpful. It's not something I would say you can rely on, though, because refractometer readings can be shifty.
Very shifty, yeah. But effectively, if you do see the higher value shadow edge moving and the one staying fixed, you've got quartz on your hand 99% of the time, because most of the time that's the only uniaxial positive gemstone that you're going to be testing on your refractometer, especially if you're looking at it in that RI window of like 1.54 to 1.56, as you say. Scapolite. Yeah. Let's talk a bit about scapolite, because...
My enemy.
Yes. Really important. Scapolite is uniaxial negative, but it is in a very similar range to quartz, and also can come in a very similar color to citrine. So you are going to do loads and loads of tests and think to yourself, do I have citrine? Do I have scapolite? I'm like a bit stumped here. So all of those tests are going to basically tell you the same thing, and your RI range is going to be pretty similar. The only real lifeline that you have is whether it's uniaxial positive or uniaxial negative. So you need to be conscious of that higher value reading, shadow edge, moving, and which one is moving, because the higher value reading is going to move if it is indeed citrine, and the lower value one's going to move if it is scapolite.
Precisely. Now, if you guys remember from our previous light episodes, all of these rays that we've been talking about have names. So the fixed one is the ordinary ray, aka omega, and the moving one is the extraordinary ray, aka epsilon. And in biaxial materials, as you should know by now, they have 2 rays, but it's actually 3, but only 2 at any one time. Simon, take over, because these Greek names could drive me crazy.
Okay, fine. So in biaxial materials, both of the shadow edges are going to move, and the 3 that you have are alpha, beta, and gamma. So alpha basically has the fastest speed and therefore the lowest RI because it refracts the least. And gamma has the slowest speed and highest RI and refracts the most. Now, beta is not going to show as a shadow edge, but it is effectively the point at which both RI readings converge on the scale. And it's kind of in between somewhere. And where it sits in between is quite important for identifying the optical character of that material.
Yes. So you're determining the optical character basically by observing which ray does the most work, which one is running furthest and farthest away from the beta. So if the highest reading, the gamma ray, is doing the most legwork, it's biaxial positive. And if the lower reading, the alpha, is doing more, it's biaxial negative. Sounds really simple in theory. In practice, it's kind of a judgment call. So when you're taking readings for biaxial stones, do them one at a time. Focus on each shadow edge separately so you can really get a sense of how they're moving.
Yeah,
Trying to
absolutely.
do both at once is just a clusterfuck.
And yeah, because like one's gonna move up the scale while the other one's also moving up the scale. And then so if you're trying to do them both at the same time, you're not necessarily going to be in an orientation where you can see the maximum birefringence. So that's why it's important to take one at a time. Look at the lower reading one, take it at the point where it starts coming back on itself, and then look at the higher reading one completely separately as you rotate the stone, and look at where that's going to start coming back on itself. Yeah, and do keep in mind the one that's doing the most work. So if it's the higher one, positive, the lower one, negative. And this is effectively what John was asking me to go over. So hopefully we've explained that in a way that is understandable and can help you figure out the biaxial positive and negative.
I would say as a hobbyist, biaxial stones are the most fun to look at on the refractometer, but as a person sitting in an exam, it makes you want to cry a little bit.
Yeah, very stressful at times.
Equally stressful, let's talk about distant vision reading. So the refractometer for these lovely clean shadow edges is depending on faceted material, but you can actually get a useful reading from gemstones that have a polished dome surface as well. So we're talking cabochons, spherical beads. It's not as accurate, but it's really useful, especially with our nemesis, jadeite and nephrite.
Yeah, because like, I don't know about anybody else, but jadeite and nephrite are so hard to identify, particularly whether they're sort of natural or dyed or all manner of different things. But if you've got something that might be jadeite or nephrite, then this distant vision reading, because mostly jadeite and nephrite is cut into some sort of carving or something, or like cabochons and things. You're not really seeing faceted jadeite and nephrite, and it's so difficult to distinguish between the two of them. But one thing that is different enough is the RI. So jadeite has an RI range of 1.66 to 1.68, and nephrite is much lower. Well, it's not much lower, but it's low enough, at 1.60 to 1.63.
Yes. So what this means is it's actually different enough that you can use the distant vision technique, which in a standard RI reading, you're wanting to go out to 3 decimal places. Distant vision just isn't precise enough for that. So you're looking at only 2. But fortunately, you've not got any overlap in those RIs. So you should be able to get a pretty strong steer on what you're looking at. So how do we do a distant vision reading, Simon?
So the process is more or less the same as you would with the faceted gemstone. Quite frustratingly, you're going to need an even smaller bit of contact fluid on the glass table, just because it's not hard enough to get a small drop of contact fluid on the table. And you want to be placing the domed surface on the fluid. Now, rather than getting your eye right deep in there into the eyepiece, you want to give yourself a bit of distance.
Yeah, the clue's in the name.
Distant vision, yeah. See, these things aren't sort of made up. They've got some.
There's a method to the madness.
Yeah, 100%. And you want to be about 30 centimeters away as you're looking through. And then when you're looking through, you're effectively going to see it's a blob.
Yeah, it's a blob.
Yeah. And you're going to see like this sort of weird, sort of either oval or roundish blob on the scale. And this blob, as you're looking at here, is most likely going to be dark, sort of in a shadow.
Mm-hmm.
So what you do is you have to move your head position and how you're observing said blob. And basically you want to be chasing the light down the scale until a point where the blob is light. And you're like, okay, so the blob is now not in a shadow, it's now light.
Exactly.
And once you see the blob going light, you want to be adjusting your head position back the opposite way until the blob is exactly half light and half dark.
It's kind of pagan in a way. So you're going from shadow to light, and then you want to find exactly 50-50. The blob is exactly half light and dark, and where the two meet, that's your RI. That's the number that you're looking for.
Yeah, so your blob's going to sort of feel like it's hovering over the scale. You'll see like this weird hovering blob. And when you can get it bang right, and you can see it's like bisected horizontally perfectly, then that is the point where you take your eye reading. And like Lucinda said, you take it to 2 decimal places, because trying to get it to 3 is just not happening. Because
I always think of distant vision as more of a steer or a guidepost than a very distinct result, but it should tell you what you need to know, especially in the case of jadeite and nephrite.
Yeah.
Where one is going to be at 1.61 and the other will be at 1.66, and that is far enough to mitigate any inaccuracies. I will say practice makes perfect on this one. It's just about being able to judge where that 50-50 point is.
Yeah, and getting your sort of head position right. You'll see a lot of people sort of doing a lot of this, and you're like, sort of like moving their head around in order to try and see the light going up and down the scale and getting it perfect. The distance vision technique can be used with any domed polished surface, and you might even need to use it if the stone's got a very small table facet. So you're not always going to get a perfect RI reading off every stone. So you need to adjust your methods accordingly.
Indeed. And again, practice makes perfect with this one. I mean, when I first started, I was so bad at the refractometer. I still wouldn't say it's like my favorite thing ever, but out in the world, it is just so useful. And it's as a guide for, things that you already have a sense of what they are. It's so useful.
Yeah, because in the practical exam, there is a section which is effectively just taking RI readings, and it's going to be RI readings of some stones that aren't even on the syllabus. So even if you look at something and you think, some of them you look at and you think, oh, well, that's that. So I kind of know what RI reading I'm expecting, but some of them are not going to be stones that you have particularly studied. So you have to trust your RI readings and trust that you're doing the refractometer correctly. And I sort of, during the mocks, the mock papers had varying degrees of success with this. Sometimes I'd be like, oh, bloody hell, I got most of them sort of pretty spot on. And then other times you'd be like, what? I've got them completely wrong. And you're like, I don't really know what's going on here. I often find
it's the 3rd decimal place. I'm not really a numbers girl. So I was like, is it 5? I don't know. Fucking 7?
Yeah, it's sort of around there. It's not a very precise science, is it? Let's be honest.
No.
I don't suppose they could really make the light be any more accurate. I suppose the thing would have to be fucking enormous.
Yeah.
You'd have to have like a giant refractometer in order to make in order to put little markings on it each.
Well, you're doing a lot of math, like birefringence can get to fuck, but.
Yeah, it's Also, sometimes I'd look at it and be like, oh, that's like 1.65. And actually, I'd only be looking at 1.6. You have to, like, you really have to have your wits about you.
Yeah. And I'd be like, okay, are we at 7 or is this 6? And then 1, 2, 3, 4.
Yeah. So, like, you genuinely
saying
have
all
to
kinds of crazy stuff.
You have to concentrate very hard when you're using the refractometer.
Be vigilant.
Yeah,
and double check it. Double check it before you move on, because the setup just takes so long.
Yeah, because getting this wrong can tell you, or to send you down a very dangerous path of identifying things wrong.
Yeah.
When you're using the refractometer, there are a few house rules, as it were, things to be cautious of. And what are some of those?
No porous stones, guys. This RI liquid is nasty, and it can stain your opals, it can stain your turquoise, so keep those porous babies away from the refractometer.
Yeah, you don't want any contact fluid getting sucked up into your precious gemstones and basically staining them and making them look shit, because
opals have enough problems to deal with. They don't need your RI fluid.
They really do. They don't need any of that. So they're crazing, they're drying out. Yeah, they're like chipping and all that shit. It's exhausting. And then they're just full of fucking contact fluid as well. It's not good.
What else, Simon?
So as we mentioned before, very important to remember, no tweezers, nothing that can scratch that important glass table.
Yep. Clean your stones. You will not get a good reading on a filthy stone. I mean, motto for life, really.
Yeah, dusty stones, things with like crap on them. Make sure everything's nice and clean.
Greasy fingerprints.
Yeah, none of that. It's also very important to get your refractometer on a solid level surface. So make sure you've got a good solid base. Make sure your table's not wobbling around, because when that thing so we told you previously that our refractometer lamp was mine was sort of like on the blink, literally on the blink. It was blinking, and it was sort of going like a little bit sort of light and dark and flashing. And when you see that, the edge moves. And if you've got a wobbly table, the edge moves. So yeah, just make sure everything's steady and secure, and you're getting a straight line that isn't wobbling around, because wobbly lines are not going to be your friend.
I would also say, it's a very stressful situation sometimes when you're using a refractometer. Make sure it's away from the edge of the table, okay? You do not need to send your refractometer flying because you've gone to use your microscope or anything.
Yeah, because that's not going to do it any good either.
Test in a darkened room. You do not need the light pollution, guys. Save yourself the drama.
Yeah, that's actually really important, because I was trying to take an RI reading the other day and I was like, this isn't working. In fact, I was using a GIA refractometer.
Those are the worst ones, I feel. You have to use them totally differently.
I hadn't used one before, and I was like, I don't really know how to use this. And it
made me feel so stupid the first time I tried to use one. And I was in a light room, and you have to, if it's a higher RI material, you have to put it up towards the top of the table. And then if it's a lower RI material, it's towards the bottom.
Very tricksy. It looks like a spaceship as well. It's like,
yeah, it's huge. No shade to the GIA people.
The eyepiece is massive. I actually quite like it now. So now that I've sort of gotten used to it, I've used it quite a few times, and I'm sort of quite cool about it.
Gemme all the way.
I like how it looks too. I think it's a bit more futuristic looking. So
it's more durable, certainly. It feels plastic.
I've got a lot of time for the GIA refractometer, but not if the light is too light in the room that you're testing. Make sure you're sort of making it at least a little bit dark.
What's our next tip, Simon?
We need to use it on a polished facet, so free from any abrasions, which we've also mentioned. And we will recap not too much RI fluid. That's very important.
It's very important. The struggle is real. Also, speaking of RI fluid, make sure that you're cleaning the contact fluid off after use, because apparently, this is according to D.D. Cunningham and Robert Webster, it's helpful to smear Vaseline on the glass if the instrument won't be used for some time to prevent corrosion. I'd never heard that before.
No, neither had I. But I suppose it kind of makes sense. You don't want a corroded glass table, do you? And if it's sort of going to sit around corroding, if you like, because I don't know if you've put contact fluid on your refractometer and sort of left it there for a bit.
It gets kind of sticky.
It goes a bit crusty.
Yeah. And it will impact your readings after a while. So keep it clean, y'all.
Yeah. And actually the top of your little fluid bottle can get a bit crusty as well. Yeah, so you want to be making sure you're not
then you're just like dropping crystals of RI crust on your thing. It's all gross.
You want to avoid the crust if you can.
And last but certainly not least, Simon, what is it?
So this is actually very important because obviously in an ideal world, all of your gemstones will be loose and not in settings and things. But
that will not happen.
That's basically not ever going to happen, really. Let's be honest. You're going to more or less be testing stones that are set into jewelry and getting good at balancing said jewelry on the refractometer table is. So I was testing a pendant the other day, and the bail on the pendant was making it sort of fall over. So a bit of blue tack comes in quite handy with that.
Blue tack is wonderful.
So you can kind of prop the bail up and then get your table flat on the thing. But also the claws. Obviously the claws are metal.
Got to be so careful. I live in fear, honestly.
Yeah, this is all goes back to your soft table and not scratching it. So you've got to be very careful with any metal anywhere near the glass table.
Especially like antique jewelry will often have really small stones that are set with really big claws.
Yeah, because people like nowadays when you've got like these really precision gem setters, they can make things really small and neat. But you know, through the ages, people and it actually some sort of low value jewelry, low cost manufacture and stuff like that, the claws are like really rough and really big, and like they're just trying to make that stone secure. They're not actually sort of considering how nice it looks. So
and they're not trying to shred your refractometer, but they will. Yeah. So make sure when you're looking at said set gemstone in jewelry that the table facet effectively protrudes beyond the claws, because if they don't, then you're effectively just going to be spinning metal around on the table, and that is a recipe for disaster. Makes me sad just to think about it.
Yeah.
Well, guys, those are our tips for the refractometer. Simon, on a scale of 1 to where do you rank the refractometer in terms of your testing techniques?
On a scale of 1 to 10, or should we do it on a scale of 1.4 to 1.83?
Let's do 1.4 to 1.8.
Okay. I would say that the importance of the refractometer will probably get up into the negative readings. I think we're beyond the contact fluid is vital.
Nice. I was going to go 1.7, losing points for being annoying.
Okay, that's fair, because it is annoying.
But again, guys, like the more you use these things, the more you'll start to understand them. Understanding the theory is important. So try and give it a little draw. But when in doubt, your refractometer is doing exactly what it says on the tin. It's telling you how much the light is refracting when it hits a material.
Yeah, simple as that.
Great. Well, we will be back with some more exciting episodes next week, guys. Make sure that you drop us an email, drop us an Insta. We are at Facet Nation Gemmology. I actually cannot speak today. It's a Sunday morning.
No, it's tricky. Yeah. Also, so I was listening to a few podcasts recently, and they are all very keen on asking people to rate and review the podcast. So actually, like if we've got some listeners out there that are keen on our podcast.
If you don't like the podcast, don't.
No, don't rate and review. But if you can spare a minute on the platform where you listen to us and give us a rating and send a little review in, I get the feeling that helps with people being able to find you.
I bet it does. And a few people have. So thank you so much to everybody who's already rated us. We've got 5 stars, Simon.
Yes, we do.
I'm sure one of them is my mother.
Touch wood. I think one of them's me.
Corporate sabotage.
Yeah. Maybe we should sort of, pay a group of people in another country to just go through and read. That's what happens to a lot of businesses, isn't it? They're all fake
completely. We'll find a Russian troll farm and make them rate us.
So but we'd like legitimate ratings and reviews, please. If you can spare a few minutes to do that, we'd really appreciate it.
And we love all of your feedback across other channels as well. So you can find us both on LinkedIn. You can drop us an email, facetnation@facetnation.co.uk. We love hearing from you guys. We have a group chat where we share messages that come through, and it makes everybody feel really happy and excited to be doing this. So thank you.
Yeah, it really does. Okay, well, yeah, that's a wrap.
Great. Have a good week, everybody. And when in doubt, use less RI fluid.
Yes, when in doubt, get your refractometer out.
Yeah, I like it. We'll put that on a sticker.
Absolutely.
All right, bye, guys.
Bye.